Good morning. I was going to go over how to add vectors together using their components. So I just want to remind you, I'm going to turn my paper over so I'm in the right place. If you have a right triangle, and I'm going to draw my x, y coordinate axis. So to the right is always going to be your plus x by convention. Up will always be plus y. And in the other directions, this would be minus x, because of course I left it off, made it too short, and minus y. So we have our angle. I'll do that in a different color. That will be theta. And then the hypotenuse of this right triangle, we're just going to use h. So thinking about your trigonometric functions, the adjacent side is going to be the one that lies on the x-axis, and then the opposite side to the angle, as we've defined it, is going to be the one that is parallel to the y-axis. So that means if we are trying to find our x and y components of this resultant vector, it will be, so the x component will be equal to the hypotenuse times cosine theta. And if you just use the definition for how you find cosine of an angle in the first place, and then rearrange it, that's how you get this particular expression. And then y is going to be equal to hypotenuse times sine of theta. And then if you have x and y and you want to find the angle, that's where we're going to use the function that the theta, the angle, is going to be equal to the arctangent or the inverse tangent, I've heard it both ways now, of your y component divided by your x component. So just keep these equations in mind when we're going through the different practice problems. So we've actually done this problem before. You still have to draw a picture so you can keep track of where the different vectors come into play. So it says that we have a bullet traveling 850 meters. So your initial vector, it's traveling horizontally. So that's 850 meters. I found my stylus, but it's still not working very well. Not meters. Newtons, meters. I've been doing a bunch of force problems. It hits a rock and ricochets, goes off at an angle for another 640 meters. And the angle is 36 degrees. So we're going to define, we have two vectors here. We have displacement 1. So I'm going to say vector 1, displacement 1 is going to be the 850 meters. And then this one where it's going off an angle is going to be displacement 2. So let's break them down into their components. So displacement 1 is equal to 850 meters. It has no y component to it in the x direction, and then it has 0 displacement in the y direction. The second displacement vector, this is where we have to use our trig functions. So first we want to find our x component. So it's going to be the hypotenuse, 640, times cosine of the angle that's involved, so 36. That gives us our x plus, now we find our component, y component, so 640 sine of 36. This gives us a displacement vector of 518 meters in the x direction and 376 in the y direction. So when you want to find the resultant vector, you just add up all the x components. So the resultant, I'm going to use a little r for that so I can keep it straight from the other ones. In the x direction is going to be 850 plus 518. So that gives us a total of 1368 meters in the x direction. X. So then you do the same thing for the y. So it's going to be equal to 0 because it didn't have any vertical component to it. And then 376 in the y direction. So your resultant vector, the components would be 1368 meters in the x plus 376 meters in the y. So then if we want to find the actual magnitude of the resultant vector, we would do, put this in red, we're going to use the Pythagorean theorem. So our resultant vector, the magnitude will be equal to the square root of the x component squared plus the y component squared. And when you do that, you get that the magnitude of the resultant vector is 1419 meters. I ran out of space and I tried to copy over a blank slide, but it's not cooperating with me. So we're going to transfer these numbers onto the next slide, even though it's got the problems on it. So the last thing you'd want to do is you would want to find the angle at which this resultant vector is with respect to the horizontal. So remember the way you do that is angle is equal to inverse tangent of your y component, which was 376 meters in the y, divided by your x component, which was 1368 in the x. So you do the math. Remember to have your tangent function set in degrees, otherwise you're going to get radians. And you end up with an angle of 15 degrees. So our resultant vector, just copy the numbers over, ended up being 1419 meters, the total magnitude, at 15 degrees above horizontal. All right, so you can go through, do the same thing for another problem. So I'm going to draw my picture first. So we go along. We have 200 meters horizontal. And then it goes up a hill. And that's 300 meters. And the angle is 3 degrees. And then it goes up another hill. And the displacement on the second hill is 200 meters. And the angle for the second hill is 8.8 degrees. So I'm going to break these down into separate vectors first. let's use green. I haven't used green yet. So this first one will be D1. The second part will be D2, and the third part will be D3. So D1, it doesn't have any vertical components, so that makes it really easy. So D1 is equal to 200 meters in the x direction. D2 is equal to 300 cos 3 degrees plus 300 sine of 3 degrees. So the components of D2 end up being 299.6 meters in the x and 15.7 meters in the y. Do the same thing for D3. So we're going to end up with 200 cos 8.8 plus 200 sine 8.8. I really need to find my good stylus. 8.8. So D3 ends up being 198 meters in x direction and 30.6 meters in the y direction. So what you're going to do is you're going to add up all of your x components. So 200 plus 299.6 plus 198, and this will give you your resultant. So you end up with 697 meters in the x direction, and then do the same thing with all the y components. So the first displacement vector doesn't have a vertical component, so you don't have to worry about that. The second one is 15.7 meters in the y direction, and the third one is 30.6 meters in the y direction. You add them together, get 46.3. If you want to find the magnitude, I'll put it up here. You're going to square both of these and then take the square root. And that will give you a value of 699 meters total. And then if you want to find the angle, remember the angle is going to be inverse tangent of your y component. So it'll be 46.3 divided by 697. Take the inverse tangent or arctangent of that, and you get an angle of 3.8 degrees. Which isn't very much. All right, so let's go on to one where it's actually talking about forces. So this one is where the first time we're going to have to talk about figuring out an angle where it's not in the first quadrant. So it's still the same idea. We still have, you're going to add up the vectors in the x and the y. So I'm going to say this one's F1, this one's F2, vertical is F3, and F4. So your x component is going to be equal to F1 plus F2, because those are the only ones that are in the x direction or aligned along the x-axis. So when you do that, you have, so F1 was 950. It's a positive value because it's going along the positive x-axis. And then we have F2 is directed along the negative x-axis, so that means it's going to be subtracted off, or plus or negative. So 1520 newtons. So we end up with an x component, f of x. That is equal to negative 33 newtons. Do the same thing for the y component. So this is going to be, you just add up F3 and F4. So F3 is in the positive y, so 1520 newtons. F4 is going down the negative y-axis, so we're going to use subtract it off, or plus or negative. So 4050. And you get a y component that is equal to 329 newtons, the y direction. So our resultant vector, it's 33 in the x, negative x, and then 329 in the positive y. So our resultant vector is taken off kind of like that into quadrant 2. It's important that you know that because we always define the angles with respect to the positive x-axis. So this is that angle that I've marked as theta on here is going to be theta the resultant, we'll say that. What you would actually report when you're solving the answer. But when you do the math, you're going to end up with an angle that is in the first quadrant. So this is where we just remember, if it's quadrant 1, you keep the angle whatever you calculate. If it's in quadrant 2, which is what we are, we're going to subtract from, you're going to take whatever angle you get and subtract it from 180. If you have it in quadrant 3, remember they go 1, 2, 3, 4. So if it's in quadrant 3, it's going to be whatever angle you calculate plus 180. And then if it's in quadrant 4, you can either say it's negative the angle, or you can subtract it from 360. So let's find our angle. And if you're going to use this system, you got to use the absolute value of whatever components you have. Otherwise, you can end up with negative signs, and it gets really confusing in a hurry. So negative tangent, or not negative, inverse tangent of 329 over 33 gives us a calculated angle of 84. So we go 180 minus 84. So our resultant angle is equal to 96 degrees. And then if we wanted to find the magnitude of the resultant vector, it would be equal to our x component, 33, squared, plus our y component, 329 squared. Take the square root of whatever you get, and you end up with a resultant magnitude of 331 newtons. And that was just so I could talk about which quadrants were which, but I did that on the previous slide. This is a similar kind of question, and I'm going to run out of time. So I want to do one. It's a little bit more typical of what you might see. So originally the picture was oriented so that it was along the y-axis. I find that kind of stuff confusing, and it makes it difficult when we find sine and cosine the way we have. So we're going to just turn the picture so that we have our positive x-axis. The car is moving along the positive x-axis. All right, so let's define our vectors. So here's F1, one that's positive, and then we got F2, which has a negative x component, the way we have it drawn. So F1 is equal to 450 newtons cosine of the angle, which is 10 degrees, plus 450 sine of 10 degrees. So we get our x component is, trying to find where I put it. Ah, there it is. 443 newtons in the x direction, and the y part is 78 newtons in the y direction. Do the same thing for F2. So you end up with 380 newtons. Cosine 30 plus 380 newtons. In this case, it doesn't make any sense to talk about going all the way around to the other side. It's easier to say it's a minus 30. Yay, phones. Okay, so 380 newtons times sine, because we're talking about the y component, of negative 30. And actually, you could put negative 30 in here, too. It's not going to affect it, though. Negative 30 degrees. So when you go through and you do the math, you end up with 329 newtons in the x direction. And then you end up with a negative 190 newtons in the y direction. So again, if you want to find the resultant, we're just going to add up the x components. So we add 443 and 329. That means that's squared. Erase. So you end up with your resultant vector is going to be 772. And then you do the same thing with your y component. Do that in a different color. So 78 plus negative 190, and you get negative 112. So if you wanted to find the magnitude of the resultant vector, you would square both. And take the square root. Yay, Pythagorean theorem. And you would get that your magnitude is 780 newtons. All right, so now let's calculate the angle with respect to the x-axis, the way we have it drawn. So we have theta is equal to our y component divided by I'm going to order a new stylus today. So 112 over 772 gives us 8.3 degrees. Now you want to go back and you want to think about it. We have a positive x component and a negative y component. So that means that we are in positive, negative. We're down here in the fourth quadrant. So that means you can either subtract it from 360 degrees, or you can say that it's 8.3 degrees below x-axis, or negative 8.3 degrees. All right, so hopefully that helped, and I'm about out of time. So let me know what you think.